All right, so we move away from the comparison test to a much more user-friendly test known as the limit comparison test. So the idea is here we have two infinite series. They both have positive terms, or again, at least beyond a certain point, all the terms are always positive. So we say let L be the limit of the sequence terms. All right, so the AK term over the BK term. We're trying to see what happens to that. And it turns out there's three possibilities that can happen with that. On the one hand, if that limit approaches some number, something between 0 and infinity, then that basically means that your sequence of your AK terms and your series of your AK terms and your series of your BK terms, the sequences that underlie them, the AK and the BK, basically grow at around the same rate. So what that means, if they approach some number, then the sum of the AK and the series AK and the series BK either both converge or both diverge. And that's because if you go back to the type of problem, then they're roughly the same. Then you're going to have a limit that's some number. And so that means they either both converge or they both diverge because they're roughly on the same level, growth rate wise. That's what this limit being going to a number kind of means for us. So then scenario number 2 is, what if the limit goes to 0? If the limit goes to 0 and the denominator series converges, then we know the numerator series also converges. Because basically what that means is B has a bigger growth rate than A. And since B is converging, then the AK has to also converge. Okay, and then finally, if the limit of AK over BK is equal to infinity, and we know that the BK series, the denominator, actually diverges, well then because the limit is equal to infinity, that means AK outgrows BK. And since BK is diverging, then we can say that AK also diverges. AK also diverges. Okay, so three possibilities. Scenario number 1, if the limit approaches a number, then they either both converge or both diverge. And that's kind of nice because then we're looking at one particular sequence, what's happening to it. Okay, if it converges, then so does our other one. If it diverges, then so does our other one. The other hand, if L is 0 and BK converges, then we know AK also converges. So AK also converges, I should say converges with S. Now, if it turns out that the limit goes to 0 and the BK sequence diverges, that doesn't say anything about the AK. Okay? Because now BK is just growing faster, it's bigger. It's just bigger. So the fact that it diverges actually doesn't mean anything about the AK. So if the limit's 0 and this thing goes diverges, then this condition doesn't tell us anything. In a similar fashion, if it goes to infinity and BK converges, well, it's going to infinity just means AK's got a bigger growth rate than BK. That's all we know. So just because BK converges, you can't really say anything at all about the AK. So we have to be careful. What these two scenarios we run into a mean, we need to try something else to compare our function to. We need to try find something else to compare our series to, because usually our series is the AK series. And we're picking some other series, BK, that we're going to compare it to using this test. And we're looking for, one of these three things to happen. One of these three things to happen. Okay, so if we run into the case where it's 0 and BK diverges, then, well, can't say anything. Try something a little bit different. If it goes to infinity and BK converges, again, can't really say anything about our sequence. We'll have to try something else. We're actually going to see an example a little later on that's going to, we're going to actually run into both of these circumstances, and they're going to require us to have to try something else. We're going to have to try something else. Okay. We'll get to that in a little bit, though. We'll get to that in a little bit.